Hi all. In this video, we're going to see about properties of skeletal muscle. So this question can be asked as an answer briefly question or maybe even as a part of an essay question. So let's quickly see what are the different properties of skeletal muscle. So we can enumerate them as follows. There are 10 properties that I'm mentioning here. First one is excitability, refractory period, contractility, tonicity, beneficial effect, trypy, fatigue, length tension relationship, force velocity relationship, and finally strength duration relationship. So in this the first four, that is excitability, refractory period, contractility, tonicity, all that are the basic properties. Then you can see that the next three are we actually do this in the amphibian experiments: beneficial effect, trapezoidal tetany, fatigue, and last three are the three relationships. Okay, I just mentioned that so that it will be easier for you to remember, or you can use a mnemonic to remember these properties. So let's see each one by one. First of all, what do we mean by excitability? See, we know that what is this graph here? It's a simple muscle curve. And what is a simple muscle curve or a simple muscle twitch? See, when a muscle is stimulated by an electrical impulse, what happens? The muscle will contract, which means the muscle can respond to a threshold stimulus and thereby generate an action potential. The resting membrane potential is around minus 90 millivolt, and once the threshold is reached, the action potential will spread along the sarcolemma, and the action potential will actually penetrate into the muscle and thereby cause contraction. So basically, excitability is the ability to generate and propagate action potential, and skeletal muscles are excitable. Next property is refractory period. What do you mean by refractory period? We have already done videos based on that. So we've got an absolute refractory period and relative refractory period. So for skeletal muscles, the refractory period is the time after which time after a stimulus when a muscle cannot respond to a second stimulus. See, suppose we stimulate a muscle, it is contracting. We give another stimulus, but that second stimulus will not respond if it is given during that refractory period. Now this is because of that ongoing depolarization. During this time the sodium channels would be inactive. See, once the sodium channels are activated by depolarization, soon after it becomes inactivated, and thus that is why we have refractory period. Now this is important because it helps in the unilateral conduction and recovery. So refractory period is an important property of skeletal muscles. Next, contractility. What do you mean by contractility? As I said before, when you give a stimulus, they respond. That is excitability. How do they respond? By contracting. So that is meant by contractility. Ability to contract in response to stimulation. So they're converting the chemical energy to a mechanical work, right? And the next one is tonicity, or the muscle tone. See, we know that the muscles, even when they are not stimulated, they are in a partial contracted state. Okay, so this is called muscle tone. And why do we have a muscle tone? That is because of low frequency impulses from the spinal cord. This keeps the muscle firm and ready for action. So the skeletal muscles have got a tone, and that is because of the impulses that they receive from the higher centers. Okay, so these are the basic four properties. Next we'll move on to our experiments. First one, two successive stimuli. What happens when a second stimuli is given to a skeletal muscle? Now that depends on when we are giving the second stimulus. Okay, so that depends on the time of arrival of the second stimuli. So based on the time of arrival, we can get various graphs. First one is the beneficial effect. What is beneficial effect? We get beneficial effect when the second stimulus is given after the point of relaxation of the previous graph. So I'll show that with the help of an example. See, this is beneficial effect. You give a stimulus, the muscle contracts. After the relaxation from the first stimulus, we give another stimulus, that is PS2. Okay, and when that second stimulus is given, you get a wave bigger than the first one, and this is called beneficial effect. Why do we have beneficial effect? Well, that is because See, after the first contraction, there is decreased viscosity of the muscle, there is increased elasticity, and there is also increased heat production, there is increased temperature. All this will cause an enhanced response to that same stimulus, and this is called beneficial effect. Next one, suppose we give the second stimuli during the contraction period. See here, we gave a first stimuli here and it was contracting, okay, and then it just began its relaxation phase, and during that time we are giving the second stimulus. See, during the relaxation phase, so what happens, the second stimulus is superimposed on the first one, that is called superposition. Here also the reason for superposition is similar to that we have seen before: decreased viscosity, increased elasticity, increased heat production. And here there is one more point, there is excess availability of the calcium because the muscle is in a relaxation phase, so all the calcium has not returned back to its source. There is a lot of calcium there, so quickly there can be increased calcium for a better contraction, right? Now what happens if we give a second stimuli during the contraction phase? See, in this graph you can see that we had given a stimuli, the muscle was contracting, and suddenly we give a second stimuli. So you can see that then that next stimuli will cause a contraction bigger than the first one, and this is called summation. So summation you get when the second stimuli falls during the contraction period. Okay, so this is one of the property of skeletal muscle. That is, when you give a second stimuli after that refractory period, you can either get a beneficial effect, a superposition effect, or a summation effect. That's a property of skeletal muscle. Next property is TREP. What do you mean by TREP? See, suppose we are going to give a series of stimuli as shown. So we give a stimuli. See, just the shape of the graph is different here because the velocity of the recording drum is different. Okay, but the principle is the same. So see, we give a stimuli, so the muscle contracts, it relaxes, and after that relaxation phase, once the relaxation phase is over, we give the next stimuli. So what happens, you can see that due to beneficial effect, the second wave is bigger than the first one, and this continues so that you get a step like fashion. Now this is called trepe or staircase. So when a series of maximal stimuli are delivered to the skeletal muscle at a frequency such that the successive stimuli falls immediately after the relaxation phase of the previous stimuli, then there's an increase in tension in the successive twitch, and that is called trepe or staircase phenomenon. Similar to this, now suppose here also we're going to increase the frequency of the stimuli. Suppose we are going to give it during the relaxation phase. What will happen? What did we study for the previous one? During the relaxation phase, you can get a superposition. So here also we can get, if we give repeated stimuli during the relaxation phase, you can get a fusion of the different contractions, and that is called clonus. So that's also a property of skeletal muscles. That is, if the frequency is such that the successive stimuli falls during the mid relaxation phase of the previous one, the muscle does not relax completely, and such a response is called clonus. And this is because of the incomplete fusion of the mechanical events. Here there's incomplete fusion causing this undulated recording here. Okay. Next is tetanus. Now suppose we are going to give it during the contraction phase. Multiple stimuli is given during the contraction phase. What happened last time? We know it is summation. Here also it will be summated. Okay, so when successive stimuli fall during the contraction period, then there is activation of the contractile mechanism occurs repeatedly before any relaxation has occurred. So the individual responses will fuse into one continuous contraction, causing this phenomenon called tetanus or tetanic contractions. And what have I written here? 25 stimuli per second is the critical fusion frequency. See, critical fusion frequency is that frequency at which we have to give the stimuli in order for tetanus to occur, and it is usually, the formula is 1 by contraction period. So these three again are the features of skeletal muscles, that is, first, the trepe or the staircase phenomenon, clonus, and tetanus. The principle is same as that of beneficial effect, summation, and superposition. But in that case, we are just giving one stimuli. Here, In the next property, we are trying to give multiple stimuli. So that's the difference between the two, but the principle is the same. Okay. Next, moving on to our next property, fatigue. So suppose we're going to give continuously stimulate the muscle. What happens? Here you can see that in this graph, initially you have a simple muscle twitch. The next 4 or 5 graphs will be bigger than the simple muscle twitch. Why? Because of beneficial effect. But after that, you can see that the contraction period increases, relaxation period increases, and finally the muscle will be in a tonic state, and that is called contraction remainder. So this phenomenon is called fatigue. It's a temporary reduction in the work capacity of a cell, organ, or organism resulting from prolonged exertion, and it is due to lack of nutrition, accumulation of waste metabolites, ATP depletion, and depletion of acetylcholine. So next we move on to the last three properties, the three relationships: length tension relationship, force velocity relationship, and strength duration relationship. So we'll see the first one. What's the relationship between the length of the muscle or length of the sarcomere and the tension developed? So you can see that when you plot a graph between the two, you will get a graph like this. What does this graph mean? In this you can see that the maximum tension developed is in this segment, that is B and C. And during this time, the sarcomere length is actually not too short, not too long. So why is it so? Let's see each points one by one. At A, the length of the sarcomere is less. But during this time, see, the actin and myosin is like this. So proper cross linkage will not be possible. We need maximum amount of cross linkages to be formed so that the tension developed will be maximum. And that is possible only in B and C, where there is optimum overlap of the contractile elements. In D, the sarcomere length is too much and there is actually no cross linkages at all. In that case, the tension cannot be developed properly. So that is why we say the maximum tension is developed when the length of the sarcomere is optimal. Okay. So at resting length, that is around 2 to 2.5, active myosin filaments overlap optimally. So if there is stretch, there is decreased overlap, decreased cross-bridge phenomenon. Too short means there would be the actin and filaments overlap, so that again there is decreased cross-linking. When it is optimal, there is maximum cross-bridge activity and maximum active force. Now, what is Frank-Starling's law? Now, that is also related to the length and tension. The only difference is that there we are talking about the length of the muscle as a whole and not of the sarcomere. So, there we say the force of contraction is directly proportional to the initial length of the muscle within physiological limits. So, if we stretch the muscle a bit before contraction or before the work is done, then the contraction force would be more. So, this property is applicable mainly for skeletal and cardiac muscle and not much for the smooth muscle, right? So that is our first relationship, length tension relationship. So next let's see what is this force velocity relationship. So force velocity relationship means, so suppose you can see in this diagram, you can see that there is a muscle and a weight attached to it. So if the force that a muscle can generate is more than that of the weight, what will happen? The muscle will quickly pull up the weight, so there will be contraction. Okay, and if the weight increases, what will happen to the speed at which the muscle contracts? Obviously it is going to be lesser. But suppose I'm going to put a heavy weight. Okay, the weight is greater than the force which that muscle can generate. In that case, do you think this muscle will be able to lift this weight? No, no movement will occur, which means it will be an isometric contraction. The length of the muscle would remain the same, only the tension developed would differ. So if the weight is less, you will have an isotonic contraction, that which means the muscle will contract. Isotonic, that means only the length will change. But if the weight is more, you can get an isometric contraction. So see, isotonic contraction means load lesser than the muscle force, so movement will occur. But if the load is more than the muscle force, then there will be no movement. So in fact, we can actually draw a graph between load and velocity, and we can see that as the load increases, see here, as the load increases, the velocity decreases. Okay, so there's an inverse relationship between the load and the velocity of contraction, and this is the force velocity relationship. And finally, we're going to see the relationship between the strength and duration, the strength duration relationship. I think we've done a separate video on strength duration relationship. There are a lot of terms here like rheobase, chronaxy and all, which determines or which shows the relationship between the strength of the stimulus and the time required for the muscle to respond. So rheobase is the minimum stimulus strength required to excite the muscle, and chronaxy is a minimum duration of 2 times the rheobase strength that is needed to excite. So longer the chronaxy, it means the muscle is less excitable, and it is used to assess the health of muscles and nerves. So I've done a detailed video on this. If you have any doubts, you can go check that. So that completes our properties of skeletal muscle. So we've discussed a total of 10 properties, of which the first 4 are the basic ones: excitability, refractory period, contractility, tonicity. Then we discussed about the beneficial effect, trapezius tetani, fatigue, and then length tension relationship, force velocity relationship, and strength duration relationship. So I hope this video was useful for you. Thank you.